Welcome back, dear students. Today we are going to start a new topic from application of derivatives, and the name of the topic is increasing and decreasing function. Okay, so before we start with the problems, it's very important that we understand what is increasing and decreasing functions. Okay, so for understanding, it's better to make use of the graph. So let me make use of these two graphs. Okay, kindly observe them carefully. So this is one graph, okay, and this is okay. So first let's observe this particular graph. Now what am I going to do is I'm going to draw one function out here. Okay, so let's say this is the graph. Okay, now just kindly look at this carefully. So let me say that this is your interval AB. Okay, so let me consider interval AB. So obviously I'm going to consider interval to be open interval. I'm not going to include the endpoints. Now I should not give you the reason why I'm not including the endpoints. You know that. Okay, so I'm not going to tell you. Right. Now here what am I going to do is let me take 1 point, 2 points in fact. So let me take point x1, let me take point x2 out here. So observe what's happening out here. So if this is your x1, and by the way, I forgot to tell you, this is your function y equals to fx. Now if I ask you what's happening out here, is the function increasing or decreasing? Now obviously you say the function is increasing, isn't it? The function is increasing out here. So if the function is increasing, so what should be the definition for increasing function? So suppose if this is your x1, then this height, so this height is gonna be how much? This is gonna be your f of x1. Clear? Very good. So this is gonna be, see, this is your x2, isn't it? This is your x2. This distance x2 means this height is gonna be how much? This height is going to be your f of x2. Okay, now which one is taller, f of x1 or f of x2? Remember, f of x2 is this height, f of x1 is this one, isn't it? So what is happening here? See, this is increasing function as I told you. Okay, so here what you see is, number one, first and foremost, here you see that x1 is less than x2, and you see that x1 is greater than x1 is less than x2, and with the help of that I saw that f of x1 is less than f of x2, isn't it? So this is one of the definition of your increasing function. So I said one of the definition. Then is there any other definition? Yes, there is one more definition. Now here we have not made use of derivative, isn't it? In this definition we don't have dy by dx or f dash. So another definition contains your dy by dx. Okay, so what am I going to do is, in this interval only, I'm going to choose any point, choose any point, your choice. Okay, so for example, if I choose this point, let's say this point. Okay, so let me call this point to be x. Just call this a x. Okay, so at this point x, that is at this point, what am I going to do is I'm going to draw a tangent. Okay, so let me draw a tangent, a rough diagram for tangent. So your diagram for tangent looks somewhat like this. Okay, now this tangent, okay, so this tangent is there. Now the slope of the tangent at this point, okay, so since you have got x here, so let me call this to be x star. Okay, so if I ask you what will be the slope of this tangent, then you say obviously this will be your f dash of, I'm sorry, this is f dash at which point? At the point x star. Okay, at the point x star. Now the question is, will this slope, this f dash, will this slope of the tangent be positive, negative, or equal to 0? That's the case, right? Okay, so if, see here carefully, if this slope has, obviously this slope has, this tangent will have the slope to be greater than 0. It's positive because the angle formed by this line is less than 90 degree. So whenever it is less than 90 degree, then your tan theta, okay, whenever theta is less than 90 degree, then less than 90 degree, then this value for tan becomes greater than 0. Okay, so that's why if the slope of the tangent turns out to be greater than 0, then it means that the function is increasing. I hope this thing is clear to you. Okay, so if this is clear to you, then let's understand what is the meaning of decreasing function. Okay, so for that also I have to draw one diagram or graph for better understanding. So let me take this particular graph. Okay, so let me take a curve out here. So the curve looks somewhat like this, let's say. No, this is an increasing function. So let me take the graph to be somewhat like this. So this is your y equals to fx. Okay, now again, as usual, what am I going to do is I'll draw some perpendicular. Okay, so let me draw this perpendicular. Okay, so why this perpendicular? Because this represents your x1, and if this is your x1, then this is gonna be your f of x1. Okay, so that's why I need to draw this perpendicular. So this is your f of x1. Now let me call this to be no, I'm so sorry again. So let me consider this to be my a, not x1. Okay, so this is my a, and let me call this to be point b. Now let me take another point out here. Okay, so this is my x1. Okay, so this is going to be my x1, and this is going to be my x2. Okay, so this is your x1 and this is your x2. Okay, now draw a parallel line out here. So this becomes your f of x1, isn't it? And if you draw a parallel line out here, so this becomes your f of x2. Remember, this is x1, so this height is going to be f of x1. Okay, and this is gonna be, if this is your x2, this height is gonna be f of x2. Is that clear? So from here to here to x2, so this height is going to be f of x2. So what did you observe from here? So first thing is, you observe that if x1 is less than x2, then f of x1 is greater than f of x2. Kindly check this. F of x1 is this side and f of x2 is this side. So what is happening? F of x1 is greater than f of x2. Okay, so next is, now this is the one definition, but in this definition I have not made use of the concept of derivative. Okay, so for making use of concept of derivative, let me make use of the tangent out here. Okay, so tangent at any point. Now this tangent, okay, so if you call this point to be, okay, so if you call this point to be, let's say x star, okay, that is the value of x is x star, then it means that the slope of the tangent at the point x star is, now see, this angle is greater than 90 degree, and whenever theta is greater than 90 degree, then the value of tan theta will always be negative. Okay, so if tan theta is negative, tan theta gives you slope, isn't it? So that means slope will be less than 0. So that means whenever you have got a slope to be less than 0, it means that the function is decreasing. Okay, now sometimes what happens is, okay, so this is the definition. Okay, so this is the definition. Now sometimes what happens is, you know, you have got this sign, okay, these signs. Now if you have got this sign, it means that it is strictly increasing. Okay, this means strictly decreasing. I hope you are able to understand. Less than means I'm talking about this sign of the slope. If you have equal to also, it means just increasing. And if it is less than or equals to, it is just called decreasing. Okay, now I'll show you one more example. Suppose we have got this graph. Okay, let's say we have got this graph, a rough diagram. Now obviously you have to consider some interval, right? So let me consider this interval, okay, a to b. Now what happens is, in this interval, let me call this particular diagram. Now if you see here, what is happening is till here the function is increasing, and till here function is decreasing. Function is increasing out here and function is decreasing out here. Again from here onwards function is increasing. So if this kind of situation happens, then the function is said to be neither increasing nor decreasing. Okay, so you have to keep that thing in mind. I hope you are able to understand what am I trying to say. Okay, so having understood this much, let's see few problems from your book. Okay, so let me take the first question. Okay, so the first question says, see here carefully, the first question says prove that the function this is strictly decreasing. So in strictly decreasing, remember your f dash of x has to be less than 0. Okay, so the given function is, okay, so let me start solving the problems. The given function is fx equals to 3 plus 1 by x. Okay, now from here find f dash of x. So differentiate both sides with respect to x. Derivative of this is 0 plus, now the derivative of x to the power minus 1 will be minus 1 by x square. Okay, so which is minus 1 by x square. Now put any value for x. Put any value for x from real line, whether it can be, whether it is negative or positive, this entire thing turns out to be positive because of this square sign. So that's why if this entire thing is positive and this sign is negative, then this entire thing will turn out to be less than 0. Okay, so it means that f dash of x is less than 0. So therefore now question is, can it be equals to 0? No, because numerator is 1, so put any value for denominator, you won't get the entire thing to be 0. So that's why you cannot put equal to sign. So that's why we say that f is strictly decreasing. Okay, so this is the first question for the day. Pause the video and note down your solution. Let's move to the next question. So next question is this one. So given function is fx equals to x minus 1 by x. Okay, so find the derivative, both side, differentiate both sides with respect to x. You get f dash of x out here. Derivative of x is 1, and as I said, derivative of 1 by x is going to be minus 1 by x square. Okay, now 1 plus 1 by x square. Now put any value for x, you will get that this entire thing is always greater than 0, and it cannot be 0, you know, the value cannot be 0, because put any value for this, okay, you cannot have this to be minus 1. See, if this is minus 1, then only you get 1 minus 1 to be 0, right? So you cannot get this entire thing to be minus 1. So that's why from here what you can conclude is f dash of x is strictly greater than 0, right? So therefore f is strictly increasing in this case. Okay, I hope you're clear with the concept and the work, right? So let's move to next question. So next question is this one, strictly decreasing on R. Okay, so given is fx is equals to e to the power minus 2x. Okay, so from here f dash of x, when you differentiate, so you get minus 2 e to the power minus 2x. Okay, now put any value for this, you know, in if you remember, if you use your calculator, you find that e will be something like 2.0 something, 03 something like that. Okay, so this is positive quantity. So if you give any power, although the power is negative, this quantity is always positive. I hope you are able to understand. So what am I trying to say here is, for any x belonging to real line, okay, the value of e to the power minus 2x is always positive. always positive. It cannot be equals to 0 also. Even if you take x equals to 0, then e to the power 0 is 1. So you cannot have this to be equals to 0. It is always greater than 0. So therefore, what we can say is, therefore we can say that f dash of x is always negative because of minus 2. Okay, so therefore f is strictly okay, so it is strictly decreasing on the real line R. Pause the video and note down the solution. Next is again a similar kind of question. So let's quickly solve this and check. Okay, so it is in the form of a to the power x. Remember, okay, so given is fx equals to 5 to the power x. Okay, so differentiate. So f dash of x. Now, as I told you, this is in the form of a to the power x. Okay, and the formula for a to the power x is a to the power x log a to the base e, isn't it? So log a, just wait a minute. So it is log a to the base e. So this is the formula. I hope this is clear to you. Now see here carefully. 5 to the power x. Since 5 is positive, it cannot be negative. As I told you, e to the power x is always positive. Similarly, this will also be always positive. Okay, and the value of this, this value, I'm sorry, this a is 5, no? So I have not written that. Okay, just wait a minute. So this 5 base e. Now the value of this is always positive again. You can check using your calculator. Okay, so what you can see here is f dash of x is again strictly greater than 0. So therefore we say that f is strictly increasing here also, right? So pause the video and note down your solution. Okay, so again we have got the same kind of situation. All these questions are very simple. So given is fx equals to log x. Okay, so differentiate, you get f dash of x is equals to 1 by x. Now my question is, now see, can you have, see, within x, within log you have got x. Can this x be equals to 0 or negative? Can it be equals to 0? No, log 0 is undefined. If you remember from class 9 logarithm chapter, if you remember, log 0 is undefined. Okay, so similarly this x cannot be less than 0. So remember, x is always greater than 0. It has to be positive all the time. It cannot be equal to 0 also. Now, as I told you, if x is greater than 0, then what happens to 1 by x? This is also always greater than 0. Okay, it cannot be negative and it cannot be 0 also. So it means that f dash of x is greater than 0. So therefore, again f is strictly increasing. Okay, so you may pause the video and note down your solution. Okay, right, so pause the video and note down the solution. Okay, so here question says, for what value of k the function fx equals to kx cube plus 5 is decreasing. Okay, so given is fx equals to kx cube plus 5. Okay, now so let's differentiate this. So you get f dash of x equals to, so k is a constant, so you get derivative of x cube is 3x square. So you get 3k x square plus 0, right? So no need to write this. Now question is asking you for what value of k function this is decreasing. So decreasing means they are saying f dash of x is greater than, less than or equal to 0. If they have said strictly decreasing, then you have to take less than 0. But since they are saying just decreasing, so you have to take less than or equal to 0. Okay, so since the function is decreasing, hence we will have f dash of x will be less than equals to 0. Okay, so we have f dash of x is 3k x square, right? So this is less than or equals to 0. Now from here what you can say is the value of k has to be again, so bring this 3 and x square to the denominator. What you are going to get is you are going to get 0. Okay, so for any non-negative, non-positive, let's say for any non-positive value, okay, the function is going to be strictly decreasing. Okay, so therefore for any non-positive value of k, the function is decreasing. I hope this is clear to you. Okay, so you may pause the video and note down your solution, right? So you mean today we'll be doing only these many sums. Okay, so we'll meet in the next class. Thank you very much.